Hello guys, I welcome you all to my channel. In this video, I will explain how to find limits of the indeterminate form 0 into infinity. I will start with the theoretical concept and then demonstrate the concept through some illustrative examples. And finally, I prepared a set of practice problems which you can solve in your uh, free time. So let's get started. Okay, so let's get started. So, as you know that the finding limits of indeterminate form is like we will be given a function like fx into gx that x tends to limit x tends to a, where we will find that limit x tends to a fx will be 0 and limit x tends to a gx will be plus or minus infinity. So the steps to solve this kind of problem is that first we transform fx and gx to either 0 by 0 or infinity by infinity form. Like uh, we can write fx gx as fx by 1 by gx. So 1 by gx will tend to 0. So it will have the 0 by 0 form. Uh, Alternatively, we can write fx gx as gx by 1 by fx, and here 1 by fx will tend to infinity, so it will have a infinity by infinity form. So once we have transformed fx gx into 0 by 0 or infinity by infinity form, we can then solve it using standard results and or along with L'Hopital rule. So let's see some examples. The first example is limit x tends to minus minus infinity x square e to the power x. So we see that if x tends to minus minus infinity, this implies that x square will tend to minus infinity square. This will tend to infinity square. This will tend to basically infinity. And e to the power x will tend to e to the power minus infinity. This is basically 1 by e to the power infinity, and this is 1 by infinity. So this will tend to 0. So we have the form is in uh, the form is infinity into 0 form. Now, step 1, we have to transform this into either 0 by 0 or infinity by infinity form. Since x square, I will prefer to transform into 0 by 0 form. So x square is tending to infinity, so I will bring it down. So this will be limit infinity e to the power x and e to the power minus 2. If I do this and then use apply L'Hopital rule, if we differentiate ex e to the power ex will always be e to the power ex and the power in the denominator, the power of x will keep on decreasing. So I think a good idea will be to transform this to rewrite this as uh, x squared by u to the power minus x. Now this is of the form uh, mm, 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 infinity by infinity, because this is u to the power minus x and x tends to minus infinity. So this is in the denominator u to the power infinity. Now we can apply L'Hopital's rule and get x tends to minus infinity twice of x minus e to the power minus x. So this is of the form this is of the form minus infinity and e to the power by minus infinity, kind of infinity by infinity form. We can then apply again L'Hopital's rule and get 2 minus infinity, we get 2 by e to the power minus x. So at this point, so u to the power minus x tends to infinity because x tends to minus infinity. So basically this is, if I bring the constant out, limit x tends to minus infinity, this is e to the power x, so this becomes 2 into 0 is to 0. This is the answer. Next problem says limit x tends to 1 minus log 1 minus x and cot pi x by 2. So we can see that when x tends to 1 minus, this implies this implies 1 minus x tends to, so 1 is a little less, x is little less than 1. So this will tend to 0 plus, it will be little greater than 0. Also pi x by 2 will tend to a little less than 1, so we can say it will tend to pi by 2 implies cot pi x by 2 uh, equals to cos pi x by 2 sine pi x by 2 will tend to cos pi x by 2. So the cos pi x by 2 will tend to cos pi by 2 and sine pi x by 2 will be 10 to sine pi by 2, which is this will 0 x. This will be 0 1 tends to 0. Also log 1 minus x will tend to uh, log 0 plus. This will tend to minus infinity. So therefore we are getting uh, minus infinity into 0 plus kind of infinity into 0 form. So now we need to transform this expression, the given function, into either 0, 0 by 0 form or infinity by infinity form. What we can log 1 minus x is tending to infinity, minus infinity. I think we can keep that intact. We can write this as that x tends to 1 minus keep the log 1 minus 1 minus x as it is and bring cot pi by x by 2 as tan pi x by 2. This becomes of the form log 1 minus x was infinity minus infinity and tan pi x by 2 infinity. Since cot pi x by 2 is tending to 0, so tan pi x by 2 will tend to infinity. So basically this is of the form infinity. Now we can differentiate, we can use L'Hopital rule and proceed further. So we differentiate the numerator and the denominator. We get minus 1 by x tan pi x by 2. If you differentiate it, what is the formula? Tan x equals, if you differentiate tan x, we get sec square x. So this will be, and also this pi by 2. So pi by 2 sec square sec square pi x by 2. Let's bring the constant outside. So we get 2 by pi limit x tends to 1 minus 6 square x pi x by 2. Let's bring it up and we get over here we have minus, so bring also the minus outside. Cos square pi x by 2 divided by 1 minus x. So this is of the form cos pi x by 2 cos pi x by 2 x tends to 1 minus means cos pi x by 2 tends to cos pi by 2, which tends to 0. So this is the form 0 by 0 form. So we again apply L'Hopital's rule, differentiate, and we get minus 2 by pi limit x tends to 1 minus cos square pi x by 2. So 2 cos pi x by 2 Uh, then we have minus sine pi x by 2, and then finally pi by 2. Uh, in the denominator we have minus 1. Sorry. So pi by 2 cancels out, and also over here we have 2. uh, minus cancels out. Here we have minus in the denominator and 2. So this becomes uh, mm, minus 2, limit x tends to 1 minus we have cos pi x by 2, and we have sine pi x by 2. Cos pi x by 2 at x tends to 1 minus is 0, and sine pi x by 2 at 1 minus, then x tends to 1 minus is 1. So this is basically 0, 1 equals to 0. So 0 is the answer. Okay, let's see the next problem. Problem number 3. Right? Okay. What does it say? Limit x tends to infinity, x a to the power 1 by x minus 1, where it is given a greater than 1. So we see that when x tends to infinity, this implies 1 by x tends to 1 by infinity, this tends to 0. 0. This implies a to the power 1 by x tends to a to the power 0 tends to 1. This implies a to the power 1 minus x minus 1 tends to 1 minus 1 tends to 0. So we have infinity into 0 form. So let's transform this into 0 by 0 or infinity by infinity form. Uh, we can see that there is a standard result. We know that a to the power x minus 1 by x limit x tends to 0 is log a. We see that kind of scenario here. So let's transform this. We would like to bring the x down. So this is, and this is 1 by x. uh, this is uh, 0 by 0 form. So instead of applying L'Hopital rule, we can clearly see if we let 1 by x equals to t, uh, uh, then x, when x tends to infinity, implies this implies when x tends to infinity, then t implies this implies t tends to 0. So the limit becomes t tends to 0, a to the power t minus 1 divided by t, and we have, the standard result. This is log e a. Let's see the next problem. The next problem says limit n tends to infinity 2 to the power n sine a by 2 to the power n. Okay. This looks a little similar problem to the previous one. Anyway, let's do it. So n tends to infinity implies 2 to the power n tends to infinity, and so 1 by a by 2 to the power n tends to a by 2 to the power infinity tends to 0 tends to 0. So therefore we are getting 2 to the power n is what? Infinity. And so a by 2 to the power n is tending to 0. So sine so sine a by 2 to the power n will tend to sine 0 will tend to 0. Therefore, this is on form infinity to 0 form. So this is limit. We can bring the 2 to the power n down. Sine a by 2 to the power n divided by 1 by 2 to the power n. And we would like to, we see that clearly it has the form sin x by x tends to 0. But we have to adjust over here, we have a by 2 to the power n. So we must have a similar thing so in the denominator. So we have to, we can rewrite this as n tends to infinity sine a by 2 to the power n divided by, we have to bring the same thing over here, 2 to the power n, and we already have 1 by 2 to the power n, so we need to adjust the a. So we already see that a by 2 to the power n is tending to 0. So this becomes limit n tends to infinity sine a by 2 to the power n a by 2 to the power n. This is a 1 equals to a. We have used the result limit x tends to 0 sin x by x equals 1. So this a is the a is the answer. Okay. Let's see the next problem. Problem number 5. It says limit x tends to 1 1 plus cos pi x multiplied by multiplied by cot square pi x. Okay. So we see that when x tends to 1 implies implies pi x tends to pi implies cos pi x tends to cos pi. What is cos pi? Cos pi is minus 1 tends to minus 1. This implies 1 plus cos pi x tends to tends to 0. Also, cot square pi x will tend to cos square pi by sin square pi. This will tend to uh, mm, tend to minus 1 square by 0, basically tends to 0. So we see this is of the form 1 plus cot pi x tending to 0. Oh, cot. Oh, this is this will tend to infinity. 1 square 1 by 0. So this will tend to infinity. So the form is 0 into infinity. Now we have to transform this into 0 by 0 or infinity by infinity form. Hmm. Hmm. X tends to 1. Uh, is with trigonometric functions, it's better to transform the limiting variable tending to 0. So if we sub, if we write x tending sorry, if we write x equals to 1 by t implies so we will get x tending to 1 implies t tending to 0. So the limit becomes t tending to 0, 1 plus cos pi 1 plus t and cot square pi 1 plus t. This is equals to 1 cos pi plus pi t and cot square pi plus pi t. Now cos pi plus theta is or sine tan cos. Okay, cos pi plus theta is minus cos theta. So this is 1 minus cos pi t. And cot square pi plus theta, cot square like all sine tan in the third quadrant tan is positive, so this will be uh, cos square pi t only, pi t. Okay. Now, mm, 1 minus cos t, 1 minus cos t equals 2 sine square t by 2, and over cos square pi t. Mm, so over there we will get cos square pi t by sine square pi t, and from here we will get okay, I think we can utilize the standard result sine limit x tends to 0 sin x by x equals to 1. Let's see, uh, limit x tends to 1, if you write these as 2 sine square pi t by 2, and this is cos square pi t divided by sine square pi t. Uh, okay, so basically fine. Cos square cos pi t will not create problem. It will become 1, and on the numerator we have sine square pi t by 2, and in the denominator we have sine square pi t. Fine, it will get adjusted. So let's bring the 2 outside. 2 sine square pi by sine square pi t by pi t by 2. I need pi t by 2. So hmm, this whole thing will become 1, and I have to adjust this pi uh, pi square t square by 4. Over here I have this, and over here sine square pi t. I need pi t. I have to adjust it like this. Okay, so what is the scenario? Pi square t. Pi square t will get cancelled. Hmm, this pi square t square will cancel with this one. Hmm, 4 will get outside, so we will get half limit x tend to 0 uh, sine square pi t by 2, sine square uh, this whole square multiplied by cos square pi t divided by sine pi t by pi t whole square. So this becomes half into 1 square into this is 1 square and 1 square, is equals to half. Answer. Okay. Hmm. The last question. This is limit x tends to pi by 2, 1 minus sine x, and this is tan x. So we clearly see as x tends to pi by 2 implies sine x tends to sine pi by 2 tending to 1. This implies 1 minus sine x tend, uh, this tends to 1 minus 0 minus tending to 0 also. Tan x equals sin x by cos x tending to sin 0 cos 0 tending to 0 by 1 tending to 0. So we get x tends to pi by 2. Oh, sorry, my mistake. X tends to pi by 2. So this is pi by 2 cos pi by 2. Basically, this tends to 1, 0 tends to infinity. So therefore, the form is 1 minus sin x tends to 0, and this tan x tends to infinity. We have 0 into infinity form. Now we have to transform this expression into 0 by 0 or infinity by infinity form. Now what we can do, mm, 1 by 1 minus sin x is tending to 0. Okay, so since 0 by 0 is the standard indeterminate form, let's try that. This equals x tends to pi by 2. Let's keep 1 by sin x intact. Tan x means cot x. So we got 0 by tan x is tending to 0, infinity means cot x tending to 0. So this is 0 by 0 form. Now we can apply L'Hopital's rule. So we get x tends to pi by 2 sin x. Differentiate sin x, we get cos x. Cos x. Cot x. Where cot x. Tan x is sec square x. Cot x x minus cos x square x minus cos x square x. Yeah, so this is x tends to pi by 2, minus minus cancels out. This is cos x, and this is sine square x. Cos x pi by 2 is 0, and sin x at pi by 2 is 1. So 1 square equals 0 is the answer. Well, these were some basic illustrative examples, and I have prepared a few set of practice problems. You can solve them in your free time, and I will attach Let's see if I can. Uh, where is the? Hmm. So this is the practice problem. You can take a screenshot and try them out in your free time. I will solve these problems and upload the solution video in the next 24 hours. That is all for this video. In the next video, I will try to come up with more harder problems for this indeterminate form is 0 into infinity and some more practice problems. And after then, we will move to indeterminate form infinity minus infinity. Thanks for watching. If you find this video useful, then please support me by subscribing to my channel and like the video. And you can also share with your friends. And also do not forget to press the bell icon so that you will be notified by my future videos. Okay, friends, until the next video, bye. Take care.